So the final step of the derivation of the aircraft equations of motion, appreciate it's been a very lengthy process, but hopefully you're all still with me, is to find the components of the gravity vector, which we said was parallel right at the start to the z-axis in the Earth axis system. We need to find that in terms of the body axis system. So from the definition of our gravity vector, we can write this first line here as just the gravity component multiplied by the unit vector in the z dash direction, because we say that it's parallel. And then from our definition of the subscript 1 coordinate system, since we said that we defined that to be parallel to the Earth axis system, we can say that this is the same as this. And then finally, after we apply the first Euler angle rotation, right, remember that's about the z1 axis, we have the unit vector in the k2 bar direction is parallel to the k1 bar direction. So that's just kind of chasing around the unit vectors in those different coordinate systems. So the Earth axis system is parallel to the subscript 1 axis system because we defined it like that, and the subscript 1 axis system is parallel to the subscript 2, or at least in the z direction, because of the rotation just about the z-axis. But now, as we've just seen in the derivation of the kinematic equations, is that we actually need this k2 bar in terms of our regular I bar, j bar and k bar. But we found that as part of our derivation of the kinematic equations, right? So we'll just use that again to rewrite our gravity vector, this, as the magnitude of g multiplied by the unit vector in the k2 bar direction, which we just said was this. So there we have finally our gravity vector, gravity equations in the I bar, j bar and k bar directions. And that completes the derivation of the aircraft equations of motion. We'll now just go on to summarize everything that we've just seen.